And now two very important formulas for finding the derivative of the product of two functions in relation to x, or the quotient of two functions in relation to x. You could run them through the formula for derivative, the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. But you don't have to do that. You can just memorize the rules, and the rules are very simple for finding the derivative of the product of two functions in relation to x. So, differentiating two things that are multiplied. If you have function f times function g, and you want to find the derivative of those two multiplied, it's very simple. It's the first times the derivative of the second, plus the second times the derivative of the first. The first function times the derivative of the second function, plus the second function times the derivative of the first function. Let me give you a simple example. Now, of course, you could just multiply these together. This is a very simple example. You could multiply these two together and just find the derivative of that. But you can also use the product rule. So the first times the derivative of the second, plus the second times the derivative of the first. So the first is 5x squared times the derivative of the second, which is 9x squared, plus the second, 3x cubed, times the derivative of the first, which is 10x, equals 45x to the fourth power plus 30x to the fourth power, which add nicely to 75x to the fourth power. Again, you could have just multiplied them out, 15x, to the fifth power, and then multiply that out. But anyway, okay. So the quotient rule. Quotient rule is also very simple. So if you want to find the derivative of function f divided by function g, then it's going to be the bottom function times the derivative of the top function minus the top function times the derivative of the bottom function all over the bottom function squared. So the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. And unfortunately I didn't come up with as nice a example here, but let's take x cubed plus 2x squared divided by x plus 6. So the bottom, x plus 6, times the derivative of the top, which is 3x squared plus 4x, minus the top, x cubed plus 2x squared, times the derivative of the bottom, which is simply 1, all over the bottom squared. And I could have just left it there, but since I started this monster, I went ahead and kind of worked it out. So if I go ahead and multiply that out, and then combine factors and factor out, this is as far as I went. Unfortunately, the x squared plus 10x plus 12 doesn't simplify neatly to x plus 6 times something else, so I just left it in this form. But anyway, that particular problem is not the point. The point is these two simple formula. For the quotient rule, bottom times the derivative of the top, minus the top times the derivative of bottom, all over the bottom squared, and then the product rule, which is the first times the derivative of the second, plus the second times the derivative of the first. And that is the product rule and quotient rule for finding the derivative of functions multiplied and divided.